minus 1 to the n is equal to minus 1 to the k plus 1, which is otherwise known as minus 1 to the k. So that's why I have minus 1 to the k there, and I pulled out a minus. But yeah, we got to be, I need to be more careful about when I differentiate power series where the power is not just x to the power n. Be careful about dropping terms there. That's the thing I was. Oh, if you're wondering, so the Larry function, by my definition, is this. The Mo function is this. The Curly function is this. And I guess the interesting thing about these functions is that if you add them together, what's the sum of Larry, Mo, and Curly? If you look at it, each one of these series contains part of the exponential series. And if you put these together, you've got everything in the exponential series. These are exactly e to the x. You're probably expecting whoop, 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 but no, it's just e to the x. And it also happens that Larry cubed plus Mo cubed plus Curly cubed minus 3 times Larry, Mo, Curly is equal to 1. This identity happens to be known for the Larry, Mo, Curly functions. A student of mine discovered it a couple of years ago in a derivation which simultaneously derives like cosine squared plus sine squared being 1, cos squared plus sinh squared being 1.
So he like invented math?
Or discovered, depending on your philosophy, I suppose, but yes. I think there is a vast literature on these functions, I just don't know it. Yeah. I digress. Anyway, you guys have other questions. Let me stop. So did that fix that? Yeah, okay. So were you stuck on the same thing as me? Oh, okay, good. So it was actually, so you were despairing because I was stuck on the same thing you were. It seemed hopeless. Oh no, that's the worst. I'm glad we figured that out today. Oh my goodness. Next. Surely someone has an easy question that they can ask me. Yes. Well, while we're waiting, find the sum of the series for me. Sum n equals 0 to infinity of, I don't know, like minus 3. Oh, how about this? Minus pi over 2 to the 2n divided by 2n factorial. See, this one is more intimidating if I instead give you the problem like this. It should be like minus 1 well, I guess the unfriendliest way to write this is pi to the 2n over 2 to the 2n times 2n factorial. I mean, in principle, you could start out the problem like that. I guess the minus is stupid. Wait a minute. Oh, I'm missing something. Minus 1 to the n. There we go. Let's get rid of that stupid minus. There we go. So anyway, the point here is to look at this and go, that's just the power series n equals 0 to infinity, like minus 1 to the n, x to the 2n over 2n factorial with what? X equals 2? Pi over 2, yeah. In other words, this is, it's cosine pi over 2, which means it's 0. Yes? You're like, I'm enjoying this part of the course. There's such a wide variety of problems we can do, isn't there? There's got to be like, I don't know, there's so many different problem types here. But they all revolve around the same thing, which is what? Taking functions and interchanging them with their power series and manipulating that, right? They're all about that. Or they're about the domain of a power series, which is ratio test every single stupid time. Except when it's not, which is geometric. So, all right. You have a question?
Yeah.
9.7, number 58. That sounds kind of scary.
Oh, yeah, my question about this was, is one of the ways to do this is just to plug a value into the last term over 3x cubed, and it's less than 0.001, then that's the answer for the value of x.
This one, unfortunately, I don't believe allows application. I mean, 55, 56, 57, these are all alternating series. So you can use the alternating series estimation theorem. But 58 is, I don't believe, an alternating series, is it? Not necessarily, right? If x is negative, it's a sum of positive terms. Right? And we're not told if x is positive or negative. In fact, you're trying to solve this. The question is, you want e to the minus 2x, and he tells you it's equal to 1 approximately. 1 minus 2x, right? Plus 2x squared. And minus 4/3 x cubed. Right? And he wants that to within 0.001 of the, that he wants that for a bound on the error. Right? So, but he doesn't tell us that x is positive or negative. I mean, if x was positive, this is an alternating series. So I could do what you're saying and just look at the next term, which I haven't included.
Well, no, what I'm saying, can you, the term 4 over 3 x cubed, can I just plug like 0.1 into that, and if it's less than,
No.
okay.
No. Now, what we have to do is we have to say, so this is, what is this? This is the fourth, this is basically the fourth Taylor polynomial of x, right? And what is Lagrange's form? Lagrange's form of the remainder says, Lagrange's error estimation theorem in this section, like, well, the useful consequence of Taylor's theorem is that the remainder of x is, let's write it up here. So we want R4 of x to be less than or equal to 0.001. This is what you want. That's how to formally state the error being less than that. X is a variable here, but we also have this to work with. The magnitude of the error term here is less than or equal to, and well, let's be specific. We're looking at 4, right? No, wait a minute, 3. And so the theorem on page 642 says that that's less than or equal to the absolute value of x minus c to the 4th power divided by 4 factorial max of the derivative, the 4th derivative at z. Now I'm going to add a little bit of. He has explained what z is in the wording. Let me just go ahead and tell you that this is for z such that minus x is less than, well, minus, how to say this? Minus the absolute value of x is less than z is less than the absolute value of x. I mean, that's the result we have to work with here. So you have to actually calculate the 4th derivative. What is the 4th derivative of e to the minus 2x? It's what, 16? E to the minus 2x. Because minus 2 to the 4th is 16. And then, if you look at that, what's the 5th derivative? Yeah, minus 32 e to the minus 2x, which is certainly less than 0. So if I want to picture the 4th derivative, it's a decreasing function, right? Between let's just for this find absolute value of x and minus absolute value of x and value of x. So decreasing function, and I don't know what it looks like exactly, something like that. The point is, the value right here, right, is going to be the. It's driving me nuts. Let's just let x be greater than 0 for the sake of this discussion as we go forward. So then this would be, this value right here would be the max, would be the max here. I could just take f to the 4th of that x, which is minus x in my current terminology, which would be 16 e to the 2x, right? And so what I have to do is I have to make this thing less than or equal to, well, x to the 4th over 4 factorial times 16 e to the 2x. And you want to make that less than or equal to 0.001. So figure out what x makes that happen. I feel like I have a sign error. I think that's, I'm almost certain that's supposed to be a minus here. I've just intuitively, that's supposed to be a minus. I have made some kind of, well, no, it is? Yeah, it is the maximum. I got to face the music. That is what it is. So, but, and that you should try to do numerically. I don't know about you. I cannot solve x to the 4th times e to the 2x equals to 0.001, you know. Okay, 16 over 24 is whatever it is. It's 2/3, you know. But like this, I can't solve that. So you have to use a numerical method to actually find the x, yeah. Anyway, this one is like way harder than the three which come right before it. All of those we can solve with the alternating series estimation theorem.
By numerical methods, you mean plugging in numbers for x?
I mean, graph the, however you want to do it. You could say, use a either graphical or numerical method to solve that equation, yeah. This one is hard. Oh, we're out of time, 3 minutes ago. But the good news is I started 3 minutes late, so it evens out. Yeah.